Oh nice! They create really cool web API to control the car. Oh no! But I don't have laptop with me to call this API. Wait, I can try to use DocAssistant.Swaggy. Let's try to test this. Okay, turn car lights on.
Sure, Oni-chan. The car lights have been turned on.
Awesome. Could you change color to red?
Sure, I have successfully changed the car lights color to red.
Could you please turn air conditioning on?
Sure, Oni-chan. I have successfully turned on the air conditioning in the car. Enjoy the cool breeze.
Could you turn the radio on?
Sure, Oni-chan. Enjoy your music. Is there anything else I can assist you with?
It was awesome. I can call any API by my voice or by chat with DocAssistant.Swaggy. And right now I will show you how this become possible. I will start the presentation by demonstrating how we upload Swagger documents, which contain information about your API. This file can be easily generated on your server by adding comments to your endpoints and payloads. The process is described in detail on the Swagger website and support mostly all server language. On this user interface, you can view the status of the most recent upload Swagger documents from a file, or directly via a URL. If your web API requires an Access API token, you can specify it here. All requests to your API will be made with this API key. At the bottom, you can view a list of previously uploaded Swagger files. You can preview them, view user-friendly documentation, or test them via the web user interface, which is generated from the Swagger OpenAPI documentation JSON file. Let's try uploading a Swagger file for a pet store. This API doesn't require an API key, so we simply select our file and initiate the upload process. At the top, you'll see the status and how the process of uploading knowledge to our AI memory unfolds. We have three main steps. First, we upload documents to Azure Storage. Then, we start chunking our large OpenAPI file into smaller parts. We split them per each endpoint and retrieve all necessary information from the file to call these endpoints. Lastly, we utilize the Azure OpenAI data model to generate embeddings for each chunk and store all chunks with the embedding in Azure Search. This will later be used to retrieve the best matching endpoints for our request. Once the document is uploaded, we preview the endpoints and can start posing questions or commands to execute our API. Okay, let's proceed to test the pet API. For instance, we could ask, could you create a pet in the store with ID 11 named Boggy and set his status to available? This API behaves like a charming Japanese anime character and provides a pleasant response. In the request, you will be able to see the curl that was generated. The response includes the body of the response, and, in Usage tab, you can see how many Azure OpenAI tokens we have utilized for this particular request. Additionally, a Swagger file is generated from the request chunks. Let's attempt to remove the newly created pet record. Moving forward, let's take a closer look at the generated Swagger file. You'll notice that there are only a few endpoints present if we compare it to the original Swagger file, which contains significantly more endpoints. In simple terms, allow me to illustrate the process flow via a diagram. Here's how everything works. Upon uploading a Swagger document, it is broken down into small chunks. Leveraging the Azure OpenAI data model, these chunks are used to create embeddings for the uploaded JSON and a corresponding embedding representation of the JSON for Azure Search. When a user initiates a request, Azure Search employs a vector type of search to identify the most suitable endpoint to assist with creating the request. All located JSONs are then merged into a new, lighter Swagger file. Following this, the OpenAI GPT model, which could be a 3-turbo or a more powerful variant, utilizes this Swagger file and the user's request to generate an HTTP request to the server. Based on the server's response, the OpenAI GPT model generates a user-friendly answer. The robustness of my implementation of the RAG pattern allows me to work with not just one API, but multiple ones. Let me demonstrate this. In our application, DocAssistant.Swaggy, we're capable of interacting with the AI not only through typing but also via voice commands and responses. For example, AI.
The score for anime ID 7 is 7.
Voice command. Show me a list of recommendations based on anime ID 14. However, it's important to note that positive results aren't always guaranteed. This tool is essentially an AI helper designed to redirect human queries to the appropriate API. If the web API on the server isn't functioning well, we cannot ensure a successful outcome.